And today's lesson on comparing is brought to you by blue light filtering glasses. Get blue light filtering glasses and reduce that eye strain. I got mine on Amazon, like 2 for $10. Okay, back to our regularly scheduled program. We are gonna do comparing and ordering. Now, when I ask you to compare, we often use an inequality sign, where you guys always say Pac-Man eats the bigger number. This would be the less than sign. It stretches into an L. And just in case this thing was frozen. This is the less than sign that stretches into an L. Less, left. And then we got our greater than sign, which goes the other way. Okay, I normally keep the bottom flat in case I have to attach an equals to the bottom. Less than or equal to, greater than or equal to. Okay, so I want to compare 1/4 and 0.245, which is 245 thousandths if I'm going to say it properly instead of all street-like 0.245. In any event, I can't compare apples and oranges. It's much easier to compare one apple to another apple and an orange to an orange. So I need to make them look similar before I compare them. So that's why we're going to convert. That's why we did the last lesson on converting. And it is my recommendation that we always convert to decimals. Because if things are fractions, you still can't compare a fraction to another fraction unless they have the same denominator, and that's more work. Do you want to do more work? Didn't think so. So let's convert everything to a decimal, which, remember, the magic button will probably work just fine. So if you put 1/4 in a fraction form in the calculator, you know what else you can do? I hope you understand that this line means what? Yeah, that's just a divide line. Before you had these nice calculators, you would have converted 1/4 by doing 1 divided by 4. When you divide, you get a decimal, okay? Anytime you put divide in the calculator, you're going to get a decimal. If you want a fraction, you got to work with fractions, okay? Just a little sidebar on how the calculator works. So 1/4 is a quarter. A quarter looks like this. Now I'm going to compare these. I can make them even more similar by making sure they have the same number of digits. So adding a 0 at the end will not affect the amount. So now that they have 3 digits, all you need to do is ignore the decimal completely and ask yourself, how does 250 compare to 245? 250 is bigger. Since 250 is bigger than 245, it would be if it was in parts also, then 0.25 or 25 hundredths is bigger than 245 thousandths. Okie dokies? Do not forget what that bar means. That bar means that something is repeating forever, and the bar is only over the part that is repeating. Your calculator will not write a bar. So you're going to have to recognize when it's actually repeating or not. And don't forget that the calculator will round automatically because the calculator screen doesn't go on forever. So watch out if it rounds it, because it might mean that something is going on forever. So in any event, don't forget negatives come before positives if we're going in order from least to greatest, and that's pretty much the only way I do it. Pay attention if tests say greatest to least. So the first thing we're going to do is we're going to rewrite all of these with the decimals lined up so we can see the place value easier. So I'm just going to line up over here the negatives, because I can put the positives on its own list. Okay, they almost have the same amount of digits. So this one has 3 after the decimal. So on this one I would add a 0. They both have a 1, so that compares the same. So we can kind of ignore that. Don't forget that these are negative. So now we're going to ignore this decimal. Which one's a lower number, more negative? A -20 or a -16? -20 would be more to the left, is left on the number line. So this is the lowest number. So we're going to write number 1 on this is what it used to look like before I added the zeros, right here. This is the first number, so that's done. This is the second number, so that's done. Is there any other negatives? No. Is there a 0? No. So let's write down the other numbers. I got 1.12 with a bar. I got 1.22, no bars. 1.12. Okay. So these look like they're all the same size, but this number is not the same as this one because this one has a line and this one doesn't. So when it has a line, what does it mean? It's repeating, and it's repeating this 2 because that's the only one it has a bar over. So let's write that in just so we're clear. So there's a 2 here, but for here it didn't have a bar, so the next number here would be a 0 and a 0. So now it might be a little bit easier. They all have the same amount of whole numbers, so I can just compare the parts. And I'm going least to greatest. So I got 122, 220, and 120. The next lowest number would be the 120, which belongs to this. This was the original number, so we're just going to label this third. Okay, so I did that. Then 122 and then 220. So then this one is next. That was the one with the bar, so this one's fourth, which would mean this one is last. So the idea is, number 1, to have all decimals. If they were fractions, I would convert them. If they were percents, I would convert them. We will get to percents. Then I'm going to line up the decimals so I can compare all the place values. I'm going to make sure they have the same amount of digits. If it's not repeating, then the next digit will be a 0. If it is repeating, write down the numbers that have the bar. Okay? If I was going to compare fractions and keep them as fractions, then it would be a pretty nice, you have to have like denominators. So going back to last chapter, if we're going to do the lowest common denominator, let's write the factors. 2 is prime, so it's just a 2. 3 is prime. 4 is 2 times 2. Okay, so I share a 2. I'm going to write that down, and then the unshared numbers are 3 and 2. 2 times 3 is 6, times 2 is 12. The LCD of 3, 2, and 4 is 12. The 3 needs to get multiplied by, look at my picture, cover up the 3. The 3 needs to get multiplied 2 2s, otherwise known as 4. There's the equivalent fraction. The 2 needs to get multiplied by 6. So I have 6/12 for an equivalent fraction. 3 gets multiplied by 4. And then I multiply this. 4 gets multiplied by what to make 12? That would be 3. 1 times 3 is 3. If this was a negative fraction to begin with and I'm writing something equivalent, it's still going to be a negative fraction when I'm done. So now I'm going to put this in order. Negatives come before positives. So that would make this one first. So this one's first. And then, since they have the same denominators, I have 4, 6, and 8. Is that in order already? It is. So this one is second, which is 1/3. And then half would be the third. I wondered if you didn't do this with common denominators, if you would have put this in the correct order. Who knows? Another good skill to know is estimation. And when it comes to fractions, it's a little harder to estimate, but I'll show you a little trick. We could change one of the numbers to compare it. You have to remember that the bigger the denominator, like this, these have the same numerator, right? We're going to compare these. If it has a bigger denominator, that means like you're going to a party with more people and you have to share the same amount of pizza. If you have to go to a party with 8 people and share pizza, you're going to have smaller slices to make it go around to everybody. So more people at the party, smaller pieces of pizza. The bigger the denominator, the smaller the pieces are. So this is what 4/7 look like. If I go to the party with 7 people and I get 4 pieces, and if I go to the party with 8 people and still get 4 pieces, I got more pizza at the party with less people. Okay? 4/7, as you can see from the picture, is greater than 4/8. Seeing as though we get the same amount of pieces, I can just look at the denominators to compare. I know a party with 7 people has bigger slices than a party with 8 people. A capiche? More people, smaller pizza pieces. Okay? Let's try this over here. Let's compare. Let's estimate. We're going to estimate everything. Like, I'm not going to turn it into a decimal. This is estimation. I'm going to compare everything to my favorite number, half. And we're going to change just the numerator or change just the denominator. If I change just the denominator, then I'm just going to compare the numerators. Okay, you get it, you get it. You're like, I'm confused right now. You're like, it's off screen. I'm like, okay, I got to move it. Stinking thing is freezing on me. Okay, so 4/7. I need to compare it to a half. What number will I keep? I need to make a half. 4 out of 8 is a half, right? I kept the 4. I changed this by 1. I got 1/8. And we just did this problem on the other page. If I get 4 pieces at a party with 7 people, they are bigger pieces than a party at 8 people. Okay? So I want to write a fraction that's a half that's close to the 5 and the 9. You're going to keep the numerator and change this to 10, right? Okay? They have different denominators, but they're the same numerator. So the party with the 10 people has the smaller slices. Pac-Man eats the bigger number. This is 5/9 is greater than 5/10. 4/9. What fraction is a half that's close to these numbers? Same numerators, so people pieces of pizza. I get more pizza at the party with 8 people. I get less left at the party with 9 people. 4/9 is somewhere less than a half. 6/11. I need a half that's close to this. That would be 6/12. Which one is 6/11 is less or greater than 6/12? It's greater. I have less people to share my pizza with. This is a random H, and now it is gone. 5/12. That would be close to a half. That looks like 6/12. They have the same amount of people at the party. So if I get 5 slices of pizza, it's less than getting 6 slices of pizza because all my pizza is the same size. Capiche? Okay, so we got a half here. Looks like 3/6. My pizza's not the same size. I get the same amount, but I get smaller slices at the 6-person party. So 3/5 is slightly greater than a half. 8/14. What fraction is one number? Just change one number and make it a half. There we go. Slices are the same. I got more slices here. 8/14 is bigger than a half. Okay? And then on the bottom here, I'm just going over the picture. We're going to put this in order. I'm going to use the picture. It's ascending order, least to greatest. That's a vocab word. Might be on a quiz. So this one's cut into 7ths. There's 4/7. You should label it. 1, 2, 3, 4, 5. That's 5/12. 1, 2, 3, 4, 5, 6 out of the 11. And 1, 2, 3, 4, 5 out of the 9. Now I want to know. Now remember, we did all of these before. This is close to 4/8, 6/12, 6/12, and 5/10. All of them are close to 1/2 by changing one of these numbers by 1. But they're not all the same amount. Where is half in the picture? Half is what fraction in the picture? I want to put a line down the middle, and it would go through here because I know 6/12 is a half. So which one's the closest to half? This one? This one? This one? Or this one? Looks like 6/11 is the closest. And if I was going to write them in ascending order, the most to the left would be 5/12. And then the next line is 6/11. And then the next one is 5/9. And the last biggest one is 4/7. 5/12 is less than 6/11, is less than 5/9, is less than 4/7. The lowest one was 5/12, and the biggest one was 4/7. Without the picture, I don't know if you would get it, unless you changed everything to decimals and did it like we did on the first page. Okay, let's see what else we have here. Anything else that's left in this packet, you should do and before you turn it in. And by the way, there's nothing wrong with using the calculator. I was just going over how to do things by hand, and hopefully you watched it all. All right, have a great day.